Hello, my name is Taryn Black, and I'm a PhD student at the University of Washington in Seattle. I interned at Kenai Fjords National Park in Alaska through the Future Park Leaders of Emerging Change program with the Ecological Society of America. For my project, I studied coastal glaciers within Kenai Fjords and how they've changed over the last several decades. In order to study historical glacier change, I used images from the Landsat satellites. These satellites take true color pictures of most of the Earth, much like if I launched my cell phone camera into orbit. These two images show Bear Glacier in 1984 on the left and in 2019 on the right. By comparing images, I can measure how the size of these glaciers changes over time. I only need a computer and an internet connection to work with satellite images. This made it much easier to switch to a remote internship during the time of COVID. I live in Seattle, which was shaped by glaciers during the last ice age. So although I didn't get to see Alaskan fjords in person, I still got to paddle in a glacially carved lake. Like Seattle, Kenai Fjords National Park has been sculpted by ice, and ice continues to dominate the landscape today. The Harding ice field and its many outflowing glaciers together cover over half the land area in the park. Glaciers are a major draw for park tourism and are an important component of the fjord ecosystems. This monitoring project helps us understand the current state of these glaciers. Are they advancing, retreating, or relatively stable? These patterns depend on climate factors like annual snowfall and melting, and geometric factors like the shape of the glacier's fjord. A glacier's current state can tell us something about its health and its prognosis for the future. This is an image of Bear Glacier from June of 2019. You can see snow-capped mountains, a lake with icebergs broken off from the glacier, and of course, the glacier itself. To measure the glacier size, I first need to trace the glacier outline, like this. I did this with spring and autumn satellite images from 1984 to 2020. This gives us a much more detailed picture of how the glacier has changed over time. The colors here represent years, where blue is the oldest and red is the most recent. You can see that Bear Glacier has retreated substantially since the 1980s, and it seems to do so in jumps rather than a smooth, continuous retreat. We can also quantify those outlines. The pink line shows that Bear Glacier has retreated over 4 kilometers, or about 2.5 miles, since 1984. The blue lines show that it lost about 16 square kilometers, or 6 square miles, of ice area. Half of that area was lost at the glacier terminus, and the rest was due to thinning and narrowing along the sides of the glacier. I repeated that process to create a database of glacier outlines for 19 different glaciers in the park. I couldn't trace an outline for every glacier in every year because of issues like clouds. But in total, I traced 547 individual glacier outlines by hand. That is a lot of clicking. One interesting case was Holgate Glacier. Observers on the ground thought it recently retreated, but my satellite observations showed that it has actually advanced since 2016, and also revealed that it has a classic pattern of advance and retreat known as the Tidewater glacier cycle. During parts of this cycle, the glacier is insensitive to climate factors. Another interesting case was Paguna Glacier. In 1964, a magnitude 9.2 earthquake shook the region, and landslides covered the glacier in rock debris. This debris insulates the glacier from the atmosphere and reduces melting. This has allowed the glacier to grow, for now. The overall pattern of glaciers at Kenai Fjords has been retreat. Of the 19 glaciers that I surveyed, Holgate and Paguna, circled here, were the only two that grew. While the rates may vary depending on specific situations for each glacier, the widespread observed retreat indicates that regional climate change is a key factor. It's important to note that satellite observations can't do everything. Discussions with people who know and visit these glaciers help a lot with interpreting unclear images or surprising results. Ground observers are also much more attuned to direct implications of glacier change, like changing habitat for kittlets, murrelets, and harbor seals. Able to observe those glaciers myself, I did spend some time in the field. FPL staff connected me with researchers at Mount Rainier National Park near Seattle, and I spent 4 days there. I helped with mountain lake surveys, set up glacier time-lapse cameras, and even got to venture onto the lower Nisqually Glacier for a glacier mass balance survey. The mentorship, teamwork, and other interactions this summer really made this internship special, both in spite of and because of COVID. Big thanks to my supervisor, Deb Kurtz, and thanks also to Eddie Kulak and Benjamin Pfister for their support. I'm happy to take any questions. Thank you.